Now we're being recorded. Now everybody's gonna have to see what I look like today. Ugh. It's my least favorite way to record. Cool. So talk about physical and chemical, heterogeneous versus homogeneous. So what's the difference between heterogeneous and homogeneous solutions or mixtures?
Homo, it's more with like salt and water, right? Where you can't see that it's mixed. And hetero, it's like you can see that things are together, which is like oil and water because they don't actually form, they separate.
Okay, I see what you're saying now. Yes, so oil and water would be hetero. That's indicating, so hetero means different, homo means same, right? So the sameness and the differentness comes from being able to differentiate between the two substances that are there, or more substances that are there, right? So for example, oil and water, you can see the visible separation of the two, right? So that's an indication that there is not uniform composition throughout, right? So if you're looking at one area of the mixture versus another area, you may have different composition, right? With a homogeneous solution, it's the same throughout, right? So this would be something like salt dissolved in water, right? It could be air, right? We have a mixture of air. You can't tell where the nitrogen and the oxygen are in the air, right? Alloys, so we talked about mixtures of metals, right? So steel would be an example of a metal where you have mixed metals together and you can't differentiate between the 2 or 3 metals that are mixed. Brass would be another example of that. In terms of metals, whether or not they're a mixture, a good way to tell is if you can't find it on the periodic table. Right? So if you're like, huh, I thought brass was on the periodic table. Go ahead and look for it. It's not there. So yeah, generally if you know a name of a metal and you look at the periodic table and it's not there, then it's probably a mixture. So
would that be also a solution?
It would, but we haven't really talked about solutions yet.
Okay.
So that's like chapter a million years from now. Chapter 9. So, but does that help, guys? So I think it's actually harder to come up with heterogeneous solutions than it is homogeneous, or mixtures rather, mostly because the heterogeneous seems like just about everything that's not homogeneous, if that makes sense. So like a sandwich or a piece of cake, or I don't know, mixing oil and water. Salad, yes, thank you. Right, I'm personally am terrible at coming up with the heterogeneous ones. The homogeneous ones are super easy for me. I'm like sugar and water, seawater, right?
Beer.
Like beer. Beer's borderline. I would never give you beer because of the fact that you have bubbles in there. And those gas bubbles make it technically heterogeneous. Depends on the temperature, really, right? Or whether it's under pressure. So I wouldn't ask that one. But vodka would be another example, right? Tequila. Yeah. All things that I can't enjoy right now. I can't wait until this baby is outside of my body. So does that help, guys? So you should be able to look at examples and determine, is this heterogeneous? Is this homogeneous? And is this a mixture, right? So that was another thing that we talked about was not everything has to be a mixture, right? You can also have pure substances, right? And a pure substance means that it's just one type of element, atom, compound, molecule, whatever, right? As long as it's just one component, it's not a mixture, right? But that doesn't mean that you can only have one type of atom. Does that make sense?
Like water.
Exactly. So you could have different molecules or compounds that have different elements in them, but there's still just one type of compound, right? That's still a pure substance. Does that make sense so far? Anybody have any questions? You doing good?
I have questions about further down in the test.
Cool.
Practice test.
Everybody okay with this stuff?
Yes, I am.
Cool. I'm not going to obviously have you draw a picture of anything because, yeah, that's nuts. So,
My picture was awful, but I did do it.
yeah, mine are too. You saw my picture of an atom. Like, it's not cute. But yeah, so mainly with this stuff, what I'm trying to convey to you that you need to know is what the subatomic particles are, right? And what they represent in terms of the atomic structure, right? So if you have, let's say 25 protons, right? And you change it to 30 protons, right? What's happened chemically?
You've changed the element.
The element.
Exactly, right? So changing the number of protons changes the identity of the element, right? If you change the number of neutrons, what are you changing?
The isotope.
Yeah, everybody all right with that?
Yeah.
So if you change the number of electrons, what have you changed?
The
Ion.
The ions, right? So it's really easy when I ask you that question that way. Do you know what I mean? So like, because not easy, but I've said it 1,000 million times. So hopefully you've had it burned into your brain by my voice. But the more difficult thing is when you're looking at questions like this, right? And trying to make sure that you understand what each one of these components represents and how they're written in a particular type of notation, right? So for the isotopic notation, right, that's always having the atomic mass up top, the number of protons down on bottom, and then the symbol next door, right?
So what about number 12, the one right above it? And it says, why are the masses of electrons neglected?
We don't really talk about that too much, but the mass of the electron is about 1,000 times less than that of the protons and the neutrons. So
Oh, okay.
protons and the neutrons are almost exactly the same weight. I think I'll get them wrong if I try and do it off the top of my head, but they're like 1.6 times 10 to the negative 27 or something like that.
Oh my gosh.
So really, really, really freaking small, but times 10 to the negative 27th is your order of magnitude for the protons and the neutrons. For the electron, it's times 10 to the negative 30, right? So it's literally 1,000 times smaller. So in terms of relative weight, it basically doesn't matter. Does that make sense?
Because they're so much smaller.
Yes.
That's why they're neglected.
Yes. Yeah.
Got it.
So
I didn't know that.
So you would have to have literally 1,000 electrons to equal or get close to the weight of one proton or neutron.
Okay.
Right? So that's another way that you could think
Like milligrams to grams.
Yep, exactly that. Yep.
You know what? You're recording this, and I've been watching all the recordings and the ones that I have attended, and I don't know how you guys listen to me. Honestly, my voice it's bad.
You don't understand how hard it was for me to come into this meeting, guys. You don't think about this, but like I get up in front of people and I talk all the time. Like I paid to do that, right? And that's fine, I can do that. But now I have to fucking look at myself when I'm doing that, and I have to go back afterwards and watch these videos and be like, oh yeah, I gotta make a note about that part. That wasn't right. I almost never watch my videos for that exact reason. Like, so there could be like really erroneous stuff going on there, and I'm just like, whatever, let it ride.
So, last night, I was catching up on lecture videos, and then in like chapter 2, Lindsay was like, okay, please don't judge me. I know this sounds like a dumb question. She had me dying, and I was like, oh my God.
It was actually a really good question too.
Yeah.
All your questions aren't good, but legitimately,
It's not my questions that I'm embarrassed about. It's my voice.
Oh, everybody, no one likes their voice on recording.
delightful voice.
That's true.
Yeah, agreed.
Yeah, nobody wants to hear their voice.
I sound like a dude.
Me too. I sound particularly awkward.
Yeah.
Sound like a high schooler. Like I get that asked all the time. Like, oh, are you in high school? You sound like a child. Like when they're calling me on the phone and then they're like, can we speak to
Your mom?
I'm like, you are speaking to me, and they're like, oh.
That's awesome.
We thought this was your daughter.
Yeah,
Michelle, you're not alone. I'm pretty sure every time I get a call, oh, honey, are you sick? No, this is my voice. I was born with it. I'd be rich by the amount of time someone asked me if I was sick. I was like, nope, just me.
No, I'm an operator voice. Thank you.
So anyways, long story short, we're all learning to live with ourselves more through this exercise. So yeah, it's very annoying, and yeah, I completely understand. But at the very least, after this semester, I'll have all of my videos made, and then my students won't have to hear themselves anymore. They'll only have to hear themselves.
So after this semester, like for your next semester, you're just gonna have them listen to these ones that come through, or?
Yeah, well, I might do like a handful of like review session type things, but mostly it's just a lot easier for me to not have to re-lecture all of this material.
Got it.
So and it gives me more time. So basically, any time that I'm spending doing this kind of stuff, I'm not spending grading or writing exam quizzes, right? All the stuff that takes me like a ridiculously long time. So it's not like I'm saving myself a ton of time, but it's enough.
Yes.
So, and I'll take where I can get it. So yeah.
Well, we appreciate you being here.
Yeah,
Yes.
and I honestly, if I thought that I could do the synchronous lecture, like every day for an entire semester, I would do it. But it's just too hard without childcare. Like,
Oh,
I don't
totally.
have a baby, so
Yeah.
Absolutely.
Yeah.
yeah. So I'm like, I gotta be flexible. I'll be on Discord at 3 o'clock in the morning, but
I know. Like I was wondering, like, why is she awake right now?
yeah,
Like, why is she responding? It's 3 o'clock in the morning.
there's a human inside my body.
But she doesn't sleep. She doesn't sleep.
Yeah.
She's very uncomfortable.
I do sleep, but I sleep in fits and starts.
Yeah. Yeah. Mine was always like an hour increment, and then I'd wake up and be uncomfortable, or my arm would be numb, or.
Oh yeah, and the bigger this guy gets, the more he's like kicking on my bladder.
Yeah.
So I literally could wake up every 2 hours just to go to the bathroom.
Yeah.
This is gonna be on the internet forever. Cool. Let's move on. Okay, so is everybody comfortable with the atomic structure type question? Cool. So 2 main types of notation that you have to be comfortable with: the isotopic notation, right, and the ionic notation. Those are the main 2.
And the ionic notation it's the charges, right?
Yeah, so I'll go through we'll do some examples together.
Okay.
I just want to cover like first if there's anything on here that you don't need to know about, that we talk about that first. So,
Okay.
Beep boop beep bop, you guys got this. So I'm not gonna ask you guys to give me the electron configuration. Again, I'm going to give you the electron configuration and ask who it belongs to.
Yeah.
Right. So yeah, but that could be the full electron configuration or the abbreviated. Okay.
So the abbreviated is where you have like the metalloids.
The noble gas.
Noble gases numbers. Okay.
Yes, exactly. And then you should also be comfortable with doing or with identifying that different elements and ions can have the same electron configuration, right? AKA they can be isoelectronic. You guys need an example of that?
Yes.
Yes, please.
So, for example, neon and fluoride, right, will have the same electron configuration.
Oh.
Fluoride being the ionic form of fluorine, right? So sodium as an ion would also have neon's electron configuration. Does that make sense?
Yeah.
So it's possible to get a question where I'm like, which one of these atoms or ions has this particular electron configuration? And there could be like an all of the above scenario. Does that make sense? Right?
Yes.
But it would have, some of the answers would have to be ions in order for that to be true.
So it would be sodium ion is the same as neon,
Oh.
but the sodium element is not the same. That's
Sure.
what. And so if you said that and you said what, like, and fluorine was fluoride would
Right.
be the same as well. Okay, but just okay, cool.
Yeah.
Thank you.
Yeah, absolutely. So that's one kind of way that I can ask that question. I do want you to know what the word isoelectronic means, right? So iso means the same, electronic means electrons, right?
And when you say isoelectronic, that's just saying like sodium ion is isoelectronic to neon.
Correct.
Okay.
Hey. Oh, the grapes. I really feel them. They're so good. Okay.
Talking.
You have a pineapple taste to them.
All right, I'll mute.
You have a pineapple taste to them.
Oh no, I'm annotating. Stop. There we go. Okay, you guys can unmute yourselves at will. But yeah, so this isoelectronic is the idea that you can have the same electron configuration for different ions with a particular noble gas, right? Questions? Lindsay, you're muted.
If you were to ask a question about like isoelectronic, would you ask for like a definition of it, or would you ask for like the electron configuration of it?
I would probably, so there's two ways that I would probably ask a question like that. One of them would be like different ions and some elements can have the same electron configuration. This is called blank, right? And then you'd have multiple choice, something like that. Or vice versa. So when an ion and an element are isoelectronic, it means fill in the blank. Not fill in the blank, but like multiple choice fill in the blank. You know what I mean? Yeah. Cool. So we'll go through and we'll do some examples of these guys because I think this is some of the new material. So we'll do some of these guys together.
I have a question, just like, I wanted to clarify that I was doing these correctly. Some classmates and I, like, we had a study session yesterday, and
Yay.
what we were thinking is this. So in terms of like naming ions, like writing the names out, I believe like the rule that we sort of like thought of was like, so the ones that you use Roman numerals for are the transition metals and the post-transition metals. Okay, and then the subscript, or not the subscript, but the
Superscript?
the Roman numeral number
Mhm.
is the charge of that ion.
Yes, which ends up being the superscript when you write it in ionic notation.
Okay, awesome. Thank you so much.
So I'm going to go ahead and stop the screen sharing here. And, oops, not my video.